All right, so now we're looking at our last type of optimization problem, and this is having to do with distance. And so you're going to see a lot of things like, oh, what is the point on the curve that's closest to a point here? So in this case, you're looking for a point that's maybe right here, where this distance is smallest. Now, for all these problems, I'm going to ask to remember the distance formula. So if you don't have this in your notes, make sure you do. x2 minus x1 squared plus y2 minus y1 squared. So last thing, all of your notes today are going to be based on that formula. So we're going to start in a second. If you're stuck on anything from your previous lessons, please reach out. Please nominate them in the forums. Please ask me through email. Smoke signals, scream into void. Just reach out and don't feel like you have to work through them all on your own. Okay? So let's get ourselves ready for notes, and we're going to talk about distance. So find the point on y squared equals 2x, which is the graph in green right there, closest to 1, 4, which is this point here. Now, as I said before, all of these are going to use the distance formula. Now, here we have some of our points already here. So this is nice in terms of plugging them in. So this is our x1 and this is our y1. So we can start out by saying, all right, our goal is to find the minimum of the distance formula. So x minus 1, I'm just dropping the subscript since now we have numbers to plug in, plus y minus 4. Now, the next thing we want to do is we still have x and y, so we want to reduce those. I will use this function here. Since we know that y squared is equal to 2x, that means that x is equal to 1/2 y squared. You could take the square root, but then you have roots inside of square roots and all those things. To me, it's going to end up being more of a headache than it's worth. So I'm going to say the distance is equal to root. X is replaced with 1/2 y squared minus 1, right? Since x is here, that means I'm replacing x in terms of y squared plus y minus 4 squared, all under the root. Now we just have one variable here, which is great, so I can take the derivative in terms of y. Now, you could argue, oh, maybe I want to simplify what's inside there, and it's not a terrible idea, but so if you want to do that, absolutely, that's what I did in the notes. I just want to show you another way to do this. What I'm going to do to be sneaky is I'm going to say, all right, well, I remember this is the chain rule, right? It's this whole function is inside of the root. Hopefully by this point, you are familiar that your root is going to be just 1 over the square root of whatever that is. So in this case, 1/2 y squared minus 1 squared plus y minus 4 squared. Then the next thing I'm going to think about is, again, the chain rule. So then I'm just taking the derivative of this inside function right here, and I can even think about them separately. So I'm going to think about parentheses, 1/2 y squared minus 1. So that would be 2, 1/2 y squared minus 1. Chain rule again with this inner function, because you can do the chain rule twice, which is just one of the reasons I want to show you this example. And that would be times the 2 comes down, multiplies by 1/2, just leaves y. Plus 2y minus 4. The derivative of y minus 4 is 1, which I don't need to write. Now, the reason I've written it like this is it's kind of nice, because when I set this equal to 0, again, I'm not worried about this denominator equaling 0. I can multiply that up and it gets rid of it, and I'm just left with 2 times 1/2 y squared minus 1 y plus 2y minus 4. So again, this is a different way to do it than is necessarily in the PDF, but wanted to show you just a nice way to do it. I'm going to divide everything by 2 right away and distribute the y here. So when I divide everything by 2, or maybe I won't, because then let's distribute the 2 actually in here, because then we'll get rid of the 1/2. I take that back. So then I get y cubed minus 2y. Distribute the second term plus 2y minus 8. These terms cancel out, and I'm left with 0 is equal to y cubed minus 8. 8 equals y cubed means y is equal to 2. Oh, I wrote squared, meant cubed. Now it asks for the point closest, which means that my answer should be in the form of xy, just like a point. So if y is equal to 2, I know that x is equal to 1/2 y squared. So x is equal to 1/2 2 squared, which gives me the point 2 for x, because that's 1/2 of 4, 2 for y, like so. If I want to check that work here in the picture, the point 22 is here. That worked out very nicely. If you have questions about anything that's come up over this week of lessons on 4.7, please reach out, please let me know, and I'm happy to walk you through any and all problems that you're stuck on.